Hello everyone. Today I'll be trying Biweekly contest 168. Yeah, I mean the last one was a disaster. I didn't even upload it because yeah. Hopefully this one goes well. Okay. Now I'm at least top 5,000 today. Okay, here we go. Okay. You're given a string S consisting of lowercase, it means performing exactly one operation by choosing case is that yeah, reverse the first key characters of S, last key characters. Smallest string that can be obtained after exactly one such operation. Okay. Okay, so basically you just find the smallest string and then okay, so if it's A B A. Okay, yeah, the first smallest one. Okay, so mn is equal to none. What are the constraints? Foresee C sit ordeal of mn is equal to C. Okay, so now which one to choose? Let's say we have A B constraints 10,000. Okay, we can just reverse everything and check, right? Okay, so I don't think we can just do it 10 power 6, it's fine. So result is equal to that. So for S, K character or reverse. The first one different letter. S of to I, A comma B is equal to S of Yeah. BACD ABBA by XZ. A. Okay. I'm going to add it to the set, right? RS would add curve 1 CPD AABP and XZY. Perfect. Let's comment this out and try running it again. First of all, okay. CPD XZY. Perfect. Give it a go. Perfect. Maximum sum of squares of digits. So you're given two positive integers, num and sum. A positive integer n is good if it satisfies both of the following. The number of digits in n is exactly num. Okay, wait. There are two positive integers, num and sum. N is good if it satisfies the number of digits in n is exactly num. Okay. Number of n is num. Okay, so num and then sum of the squares of the digits is n. Sum of the digits is sum. Okay, so let's define this function. Define good of x. Okay. So if, well, let's say digits, right? Number of digits. Number of digits. Okay. Count is equal to 0. Sum is equal to 0. So while x digit is equal to x mod 10, and then x is equal to x divided by 10. So s plus equal to digit count plus equal to 1. So if count not equal to, let's say initially n is equal to x. So initially, if count is not equal to n, or s not equal to su, s not equal to su, return false. If now we just return true. Okay, return as the score of a good integer n is the sum of the squares of the digits. Define score of a good integer. So of an integer, well, let's have a score also here. Return false score. Okay. Return a string denoting the good integer n that achieves the maximum score. If there are multiple possibilities, return the maximum one. Number of digits in n. Okay, what is the constraint of n? N is 10 power 5. Input is num to number of digits. Okay, the number of digits. I mean, isn't this a binary search? Is it a binary search? Okay, is it a binary search? Now there can be. Okay, it is not a binary search. Let's say a number is good. There can be a greater number which is also good. Okay, let's say a number is not good. Then we need to check both the sides of the spectrum. But I think there should be some greedy way, right? Sum is 3. Return a string denoting the good integer n that achieves the maximum score. Okay, maximum score. Now, are the digits unique? The digits need not be unique. Okay, one observation is that, okay, we can look at the question in another way. So let's say we have digits 0 to 9, and the first digit is always non-zero, right? And then we need we need to form, so the sum should add up to num, the sum of the digits should add up to sum, and the number of digits is that. Okay. How do we maximize the score is the question. Let's say the number is 5, sum is 4. So 4 is 0, 0, 0. 16, or you can do 3 square plus 1, 10. Right, right. If the number is, so essentially we need to split them. What is 30? Maybe all this is useless. So let's say our string is equal to that. So count is equal to 0. And then target is our sum. So current curve sum is equal to 0. So if curve, let's say s is equal to sum initial. So for while s greater than 0, while s is greater than 9, let's call this result s minus equal to 9, and then res plus equal to 9, count plus equal to 1, while count less than num is equal to 1 is equal to 0. Now, is it always valid? You have exactly 1 digit. The first case is if num star 9 is lesser than sum. Okay, then we return that. So if next, if s greater than 0 to 1, count plus equal to 1, s plus equal to s. uh, s plus equal to s. Okay, and now let's return result and see what happens. 30, 98, 10. I know if this is gonna work. Am I missing anything here? Let's try 5 and 4. Right? 5 and 14. 5 and 14, right? Perfect. Wow, that was quick. Really good. You're given two integer arrays, nums. I mean, let's see my ranking. 4,000, not good enough. We need to solve this. You're given two integer arrays, nums1 of length n and nums2 of length n plus 1. You want to transform nums1 into nums2 using minimum number of operations. Okay, what is one operation? Perform the following operations. Okay. Okay. Increase number by 1, decrease number by 1, append 1. Okay, you can increase, decrease, or add that to the end. Return the minimum number of operations required to transfer nums1 into nums2. So, one observation is that uh, you only append once, right? That's one observation. Okay, and now okay, how do we go about this problem? Now, what are the constraints? First of all, 10 power 5. This is quite tricky. What are the points for today? 6, 5, 4, 5. Give me two arrays, nums1 length and nums2. Okay. Okay, this is not that hard. This is quite simple. It's O of n solution. And the last part is the tricky part, that's all. Okay, let's say we have a flag is equal to false initially, right? So for if the last digit doesn't exist, then we'll have to perform extra operations. So here, let's have a scene. I just want to have a scene. Okay, so let's have Okay. Okay, so for ops, so initially we have ops is equal to 0. So for I comma n in enumerate of nums1. Okay, right? So if so ops is equal to the absolute of nums1 of I minus nums2 of I, right? Okay, that's the first thing. And now when do we keep flag as true? So if nums2 of -1 in range, so let's have L and R. L is equal to minimum of nums1 comma nums2. R is equal to maximum of nums. Okay, it's nums1 of I. My bad. I nums2 of I. Nums2 of I. Nums2 of I. Okay, that's perfect. So if in range L to R plus 1, then we don't have to add any extra operations, right? So we don't have to add any extra operations. That means flag is equal to true. And then if flag, then we return ops. Now if not flag, so if not flag, so extra is equal to 0. So we need to go away from the peak and come back. So minimum is equal to, initially let's have it infinity. So for I comma n in, now we can do that in the same loop, I guess, right? Extra is equal to, okay, fine. Let's have a minimum float of infinity. Okay. Okay, so div is equal to absolute of, here let's have absolute of okay, let's have div 1 is equal to absolute of um the last element. So let's say our last is equal to nums2 of -1. That's what we need, right? So absolute of um our lowermost value and our required, and diff2 is equal to absolute of, and then last, can you pass in two functions with absolute? Right. R minus last. Now it's 2 times the difference. Is that okay? Let's say we have 1 and then we need to go to 3. So we go to 2 and 3, come back to 1. Okay, yeah. And then our minimum is equal to minimum of mn diff 1 comma diff 2. Now if not flag extra is equal to 2 times minimum and return ops plus extra. I think this should be fine. Let's see what happens. Output is 433. What did we get? 443. What's the second one? We append 1. We can append, you don't have to append, and you can append the middle also. It has to be outside the limit though. Wait, so okay, so that is 1. Decrease us to 7. Okay, we have 2, 8. Example 1 is fine, right? 1 is 4. 1, 3, 6. We have 1. Let me work it out. 1, 3, 6, 2, 4, 5, and 3. So now 3, we don't need any extras. So the answer should be 1 plus 1 plus 1, which is 3. Why is it 4? Okay, wait. Okay, appending is an operation. So it should be. So if flag, it's plus 1 is, I guess. Wait, appending is one operation. So appending itself is one operation, right? Shouldn't we be ops plus 1? Two, 8, and 173. 2, 8, 173. And it is not 2 times, is it? But it is 2 times. No, it's not 2 times. It's the difference between. So we need the nearest number. So minimum is the nearest difference. Extra is equal to mn. 443. Perfect. Is that right? 443. I think that should be fine. Let's give it a go. Did I submit? Perfect. Amazing. Okay, that was my fastest Q3, man. Really good. Okay. Okay. Okay, now the big guy comes. Okay, so you're given an M into N matrix. How many users have gotten this? 800. Matrix of positive integers. Ways to choose exactly one integer from each row. You're given an M into N matrix. Return an integer denoting the number of ways to choose exactly one integer from each row. All the chosen integers is 1. Exactly one integer from each row. So that. So we're supposed to choose one from each row, and all of them should basically be coprimes. The greatest common divisor for all of them should be 1. So here you can either choose 1 and 3, 1 and 4, or 2 and 3, which is 3 ways, right? Now, how do we do this? What is the constraint? Oh, it's only 150. But yeah, there are 150 options. Okay. Now, M 150 and 150. This is really interesting, and I don't doesn't seem very hard to understand for sure. Let's not forget the mod. So mod is equal to 10 power 9 plus 7. Okay. Okay, how do I even go about this? So I have to choose one from every row. Now, if that one is a prime number, it's pretty straightforward. Is it? So we have 5 and 10. No, it's not straightforward. Yeah, so what is 150 into 150? It's, let's say 10,000, 10 power 4. Hmm. So let's say we have a set of numbers. Now the numbers, what can they be? The numbers also lie under 150. Okay, so for row in matrix, for I comma row in matrix numerate of mat, we can sort it. So mat of I is equal to sorted row. Okay, now let's just print out the matrix. So for x rn mat. Um, I have no clue how to solve this. And I don't want to give up. As much as I don't want to, I'm gonna try this later. Yeah, yeah. I'm gonna have dinner and yeah, I don't think I can solve this today. I'll have a look at the solution later, but for those of you watching, yeah, don't give up like me. Goodbye.